Like I said, today we're talking about writing and graphing inequalities. So let's start with just writing linear inequalities. Taking a sentence and just translating it into an algebraic statement. So an inequality is some mathematical sentence that compares expressions. Okay, when you're comparing two different things, they can compare in essentially three ways. Either one thing is bigger, it's smaller, or they're the same. Okay. And the symbols that we're going to mostly use, there's actually one other one that's not listed here, and we'll talk about that another day. But for now, we're going to be just looking at these four inequality symbols. So hopefully this is something you've seen in 8th grade or before. So this should be a little bit of review. But do y'all recall, like for instance, what this symbol means?
Greater.
Yeah, greater than. Exactly. And there are other phrases that we'll see that sort of mean the same thing, and we'll come back to that and kind of fill in a little bit more later. What about this one? So what does it mean when you have that exact same symbol, but you see a little line underneath it, like it's underlined? Yeah, it means it could also be equal to. So like if you see the less than symbol with a little line underneath it, yeah, less than or equal to. And finally, this one right here. Exactly, yeah. Greater than or equal to. So the first thing that I want you to be able to do is to take just like an English sentence and sort of translate it into an algebraic statement. So let's look at these two. There's a few more on the back that we want to do that too. If you know you kind of struggle going from these English sentences to mathematical algebraic sentences, it helps to sort of underline sort of the key numbers and phrases. So like for this one, like in other words, like for these, I'm typically just going to underline 3 different sections: the left side, the right side, and the part that indicates which inequality symbol we're going to use. So like for this one, I would say, 12, that's going to be the left side, is greater than or equal to, that's telling us what the symbol is, 5 times a number n. So just write 12 is greater than or equal to 5 times a number n. Don't write like 5 cross n or 5 dot n. Whenever you're multiplying a number by a variable, you typically just don't write the operation in between, and it's implied to be multiplication. So you just write 5n. That'd be good. Okay. 1/3 of a number h. So does anyone know, like when you see the word of, what does that indicate? Yes, ma'am. Not divided. Multiplied. Yeah, if I say if I ate 1/3 of the pizza, so you have one pizza and you multiply it by a third, you get a third. Yeah. So whenever you see that I think that's a pretty subtle thing that is easily missed. But if you see of, usually that's going to indicate multiplication. So 1/3 of a number h, you'd write like 1/3 h, 1/3 times h. 2 groups of x would be like 2x. Is less than, and then 15. So most of these are going to be pretty straightforward. There are going to be a few that I think will be a little tricky, but most of them shouldn't be too bad. Any questions so far? All right, let's do there's a few more on the back here. All right, 7 is less than or equal to, 7 less than or equal to the difference of a number q and 6. So yeah, what operation's indicated there? Yeah, subtraction. So whenever you see that word difference, that's going to indicate subtraction. So yeah, q minus 6. The sum of a number u and 14. So that's going to be the left side. But what does sum indicate? Addition, yeah, adding. Yep, exactly. U plus 14 is more than 6. Now later on, we won't even do this today. We'll do it next time. We would eventually want to solve this, and that's kind of where we're going with this. But for now, we're just kind of setting it up. Number 5, the quotient of 3 times the number. I think there's a typo here. Let's just call the number A. That's kind of weird. Yeah, that doesn't read correctly. That's okay. We'll just call the number A. And 7 is less than 4. So the quotient of 3 times a number A, so let's just say number A, and 7 is less than 4. I think the right-hand side is going to be a lot easier to write because it's just literally 4. So is less than 4. We got that part. But what's going on over here on the left side?
It would be 3A minus 7.
So quotient, what does quotient mean? Yeah, that's the answer to a division problem. So you're going to have basically a fraction, right, when you have a quotient of 3 times the number A and 7. So the quotient of 3 times the number A and 7. So this first part is what's going to be up in the numerator, and the second part will be in the denominator. In other words, it's saying divide this by this is another way to think about it. So you would just say 3A divided by 7 is less than 4. So the second thing we're going to look at here is how to verify whether or not a number is a solution to the inequality. Okay? So a solution of an inequality is a value that makes the inequality true. Okay? What we're going to be dealing with are situations where you have more than one solution, though. Okay? So especially with these inequalities, we are going to describe the group of solutions because there's going to be more than one. Like if it's x greater than 5, you're going to have infinitely many, right? So you have a lot of them. But that whole group of values that satisfy the inequality, we call the solution set. In other words, there is a set of values, a group of values that could work for that inequality. So some of these questions, which should be pretty easy to figure out, are just asking you to say yes or no, is this a solution? So like for this inequality, d minus 7 is less than 12, is 19 a solution? So how would you determine that?
By plugging it in.
That's right. That's all you got to do is plug it in, right? So you're going to take this number, substitute it in for d. 19 minus 7 is less than 12. Well, what is 19 minus 7? 12. Is 12 less than 12? No, this is a false statement. So what does that mean? How can we answer the question that's being asked? Which is 19 a solution?
No.
No, 19 is not a solution. Okay, so that's probably the best way you can answer that. If you just write the word no, that's fine. But when you want to show whether or not these are solutions, I do want you to show these steps. Like actually show how you're verifying. Don't write yes or no and leave everything else blank. Like actually show that you know that you're plugging it in and verifying it. Yes, sir. So let's look at number 7. We want to test to see, is 1 a solution to this inequality? So just like with the last one, all we're going to do is just substitute in 1 for the variable n and do the arithmetic and just see if it's true. So 3 times 1 is 3, and 3 plus 6 is 9. So keep in mind that this is a sort of a yes or no question. Is 9 greater than or equal to 9?
Yep.
Yes, it is. It is at least one of those things. So because this ends up in a true statement, we can say that 1 is a solution to the inequality. 1 is a solution. number 10. We're going to substitute -6 in for m. Okay. So we've got 10 is less than or equal to 3 minus -6 over 2. So you just have to be careful here. We're dealing with a lot of negatives. You know, typically you would have a calculator just ready to go that would take care of all this for you. But -6 divided by 2 would be -3. But then we would have 3 minus -3. So what's a better way of saying that? You know, when you're subtracting a negative, what are you actually doing? Yeah, just adding. So we're just going to change this to 3 plus 3. So is 10 less than or equal to 6?
No, that's wrong.
No, that's a false statement. Okay? So that means that -6 is not a solution. In other words, -6 does not satisfy the inequality. Number 9. We're going to throw 7 into x. 4 times 7 minus 25, is that greater than -2? Well, that's what we're about to find out. 4 times 7 is 28. 28 minus 25 is 3. Is 3 greater than -2?
Yes.
Yeah, that's definitely true. Make a little note. Yeah, that's true. 7 is a solution. There will be, right? There will be infinitely many solutions, right? So, in other words, like if this simplifies down to something like x greater than 5, then any number bigger than 5 would be a solution. So 6, 7, 8, 9, 10, all those. So we're just testing, like, hey, is this actually in the solution set or not? And saying yes or no. So to follow that up, we're going to sort of put those two ideas together, where we interpret a statement and then verify whether or not something's a solution. These should be pretty straightforward. Okay. The what? Okay. So this one says in 1997, Superman's cape was sold at an auction for $17,000. It was the best money I ever spent. Write an inequality that represents the amounts of the losing bids. So what does that mean? The losing, what has to be true about the losing bids?
Bid less than 17,000.
Exactly. So you would say something like x is less than 17,000. Right? So this next one says on a fishing trip you catch 2 fish. The first one weighed 1.2 pounds, and the second one weighs at least half a pound more than the first. So let's write an inequality that represents the possible weights of the second fish. So that second fish is at least 0.5 pounds more than the first fish. So if it's at least that much, which inequality should we use here?
Greater than or equal to.
Greater than or equal to. 1.2 was the weight of the first fish, plus the extra weight from the second fish, because it's at least 0.5 pounds more than 1.2. So is 2 pounds a solution to the inequality? Yes. Right? And that's because 2
is equal to 1.5 plus 0.5.
is equal to?
Is greater.
Is greater than or equal to?
But
Wait a minute, is it?
wait, can you move your paper a little bit?
Oh, you can't see it. Okay, yeah. What is 1.2 plus 0.5?
It's 1.7.
No, 6.2.
Never mind. 6.2. It's
It's 1.7.
It's
0.7.
Oh, wait, no, it's 1.7.
It's 1.7.
That's 1.5.
This man don't know how to do
That's
I
1.5.
know.
If it's 1.2 plus 5, I'd be correct.
But it's not. Wait. Keep it right there.
So the last one is talking about the water temperature of a pool. It says it must be no less than 76 degrees. It'd be too cold otherwise, I guess. So to write an inequality to represent that, you would say x.
Is less than or equal to.
Well, it doesn't say less than, it says no less than.
Oh.
So in other words, like it's not less than.
Oh!
Yeah, greater than or equal to 76.
I see.
So it says the temperature is currently 74 degrees. Is that okay? No. Right? Because 74 is not greater than or equal to 76. Okay. How many degrees would we need to increase it by? Yeah, 2. Let's talk about how you graph numbers on a number line. Okay. So anyway, the solution of an inequality, I'm sorry, not the solution, the graph of an inequality shows the solution set of the inequality on a number line. Okay. Now I think you may have done this in 8th grade. Correct me if I'm wrong. Maybe you didn't. But you may have talked about like open circles and closed circles when sketching these out. So that's basically what we're going to talk about here. Okay, so when the number is not a solution, you will use an open circle to note that. And I just mean like you just draw a circle and you don't fill it in. Okay? When the number is a solution, you will use a closed circle. Meaning you draw a circle and you just fill it in. So the open circle you'll use in cases where you have like less than or greater than, and a closed circle you'll use in cases where you have less than or equal to, greater than or equal to. Okay? Finally, you'll use an arrow either pointing to the left or to the right to show where the solution set is. Okay? So for example, if you have x greater than or equal to 3, the first decision you need to make is at 3, or I should say, is 3 a solution to this inequality? Is 3 greater than or equal to 3? Yes or no? Yeah, it's greater than or equal to 3. Like it's equal to 3, right? So it is also greater than or equal to 3. So since 3 is a solution here, we're going to put a closed circle at 3.
And go right.
Yep.
And we want to draw an arrow to the right because the statement is saying that x is greater than or equal to 3. So we're going to point towards where the solutions are.
Okay.
Yeah, we're almost done. Let's do a few more examples. Is this going to be an open circle or a closed circle?
Close.
Close.
It's close because it's greater than or equal to. Or equal to. is
And
what
which
they say.
direction should the arrow point?
Left.
Left.
Roll answers.
Number 15 should be an open circle at -1, pointing to the right. Yes, sir.
It's just
My
basically.
teacher taught us a trick last year. If the sign is like facing that way, then it goes that way.
Yeah, that's what I did.
Yeah. So let me add to that. Okay. So if you didn't catch what he just said, and sometimes it's kind of easy to get confused with which way the arrow should go. But a little trick you can use is that if you look at the inequality symbol itself, it sort of looks like an arrow and it's pointing in the right direction. Okay, that's the direction the arrow needs to go. So, you just kind of think of this as an arrow. However, let me caution you, this only works if the variable's on the left side. So what I would recommend is if the variable's on the right side, you go ahead and just flip the whole inequality. Like, for instance, if you solve your inequality and you get something like 3 is less than x, then before you start to graph it, rewrite it as x greater than 3. So you just flip the whole statement, and then the arrow will be pointing in the correct direction. Okay, so just be careful about that. That's a good question. X less than 1, open circle going to the left. Okay, and I also want you to be able to go from the graph to the inequality. So down here, is this going? What inequalities being shown here?
A 1
X
is
is greater than 1.
Good. X greater than 1.
X is less than 0.
X less than 0.
And then 3 is greater than.
Well, careful. You want to
Less
start.
than or equal to.
X is greater than or equal to negative 3.
And now X is.
And
less than or
X
equal
is
to-
less than or equal to 3.
Or negative.